and welcome to this pre-recorded feedback on the Pearson Edexcel GCSE Chemistry examinations for summer 2019. This session will reinforce some of the issues raised in this year's examinations from the answers provided by the candidates sitting the papers in May and June of this year. The aim is for you to take on board the advice given here to help you prepare your students for future examinations. Before you proceed with this pre-recorded session, you may find it useful to pause the recording and become familiar with the examination papers, mark schemes and examiners' reports. Here are the aims for this pre-recorded feedback session. This session will look at these key aims. We've chosen to concentrate on these areas as here there have been some changes from the old specification to the new one. Extended open response questions is an area of the examinations where many students do experience some difficulty, particularly on the foundation tier. For the combined science paper, the contribution is 10% of the marks. For the single science chemistry papers, this increases to 12% of the marks. Each extended open response question is targeted at the whole grade range for that paper. So that means grades 1 to 5 for the foundation tier and 4 to 9 for the higher tier. To assess practical skills, at least 15% of the marks available will assess not only the core practicals as listed in the specification, but also a variety of other practical aspects where taught principles of the subject may need to be applied. Such examples would include devising an experiment to find out what happens to the mass of a solid catalyst during a reaction as tested in the foundation paper 2F, or describing the remaining steps of a method to determine the mass of ethanol required to raise the temperature of water by 30 degrees as tested in the overlap questions of papers 2F and 2H for chemistry. Mathematical skills. In chemistry, there's a minimum of 20% of the marks available for mathematical skills across the qualification. These skills are listed in Appendix 1 of the specification and are assessed on both the higher and foundation tier papers. These skills cover the usual types of calculation as shown in the specification. Here you should note that high-order mathematical skills are only assessed on the higher tier paper and are shown as bold statements in the specification, e.g. statements 1.50, 1.51, 5.10, 5.17 and 7.14. But we also have to test at least 20% of the marks available for mathematical skills on the foundation papers, and these can be covered by skills such as balancing equations, working out the formula of an ionic compound from its constituent ions, and graphical work. The final theme is the use of command words. These are listed in Appendix 2 of the specification, and it is with these that we test the specification in the examination. This first section concerns the extended open response questions. As mentioned previously, these have to cover the whole of the grade range targeted by the tier. So the F tier, even a grade 1 student may be able to give an answer that will gain some credit. This first response came from question 9D on Chemistry 1F paper, which was also question 6D on the Combined Science 2CF paper. Student response 001. This was given level 1, 0 marks. This question was about the formation of sodium and chloride ions from their atoms and the arrangement of the ions in their solid. It appears that the candidate missed the point that sodium chloride is an ionic compound and contains ions, as the answer later on described covalent bonding. During the marking, any incorrect or irrelevant material in the answer is ignored, unless it contradicts something already given which is relevant. So here the part about sharing of electrons was ignored. For this question, many candidates make no attempt at answering the question. A significant number just described the electron configuration of both atoms, just as this candidate did in the first paragraph. but a substantial amount wrote about sharing of electrons when they were describing transfer of electrons. For example, sodium shares its outer electron with chlorine, so sodium and chlorine now have full outer shells, when they mean sodium gives its outer electron to chlorine. Student response 002. Here's another response that did not perform well. This question appeared on the Chemistry 1H and Combined Science 1CH papers. The candidates were told that the table showed the properties of 4 substances that they had to identify, the solids as copper carbonate, copper oxide, magnesium or sodium hydroxide, and explain how they used the information to deduce the identities of the solids. The candidate gave incorrect chemistry, and after ignoring that, little left could be credited. This scored 1 mark for correctly identifying solid B as magnesium. Overall performance on the chemistry paper was skewed toward the higher levels 2 and 3, whereas on the combined science, most candidates achieved either level 1 or level 2 on this question. In general, performance on the extended open response questions tends to be poor for the foundation tier cohort, particularly for the combined science. However, many candidates do produce some very good answers when tackling the 6-mark questions. This response came from the Chemistry H tier paper 2, question H, which was also question 5C on the Combined Science 2CH paper. Student response 003. The candidate related the particle size of the calcium carbonate lumps to the surface area and frequency of collisions and concentration of the acid frequency of collisions to account for the results shown in the table. This was considered as level 3, answering 6 marks. You'll see in the mark schemes we've now included some marker guidance we produced to enable the markers to obtain a better match between the written work and the level of the answer. You'll see in the marker guidance a progression going from level 1 to level 2 to level 3. To decide whether the work is the higher or the lower mark, you'll find a comment about this in the top right-hand box of the marker guidance for that question. You'll find this marker guidance useful when marking work by your own students. Some areas within all of the papers where candidates did not perform well on the extended open response questions. Concerning these points, by ignoring the extended open response question, candidates are not answering 10% of the paper for the combined science and 12% for the chemistry papers. Incorrect or irrelevant material is ignored in the marking, providing the incorrect does not contradict with any correct statements. Here are some suggestions for improvement and areas to focus on in teaching and learning. Practical skills are tested within the written papers and contribute to a minimum of 15% of the marks across the assessment. The apparatus and techniques to be assessed within the examinations are listed in Appendix 4 of the specification. From the answer seen from this summer practical work is a feature of many schools' chemistry courses. Students having a limited experience of practical work find questions about non-core practicals quite challenging, as they find it difficult to deal with these unfamiliar situations. This question was on the foundation tier papers for both chemistry and combined science. This was question 5A2 on chemistry and question 3A2 on combined science. The question was about investigating the reactivity of 3 metals in their reaction with dilute hydrochloric acid and observing the amount of effervescence formed. Student response 004. It is clear from this candidate's answer that they did not understand controlling variables, and this answer scores 0. The variables we were hoping to see included volume of acid, concentration of acid, temperature and size of metal pieces. Many candidates incorrectly thought that the time the metal was in the acid or the size of the test tube were suitable variables to control. Some repeated the question by suggesting controlling the mass of the metal. It appears that many candidates at this level are unsure about controlling variables. About 60% of the candidates did score 1 mark here, usually for temperature or acid concentration. Of concern were the 15% of chemistry candidates and 30% of combined science candidates who scored 0 on this question. The next question was targeted at challenging the higher ability students on the chemistry H tier and combined science paper 1, and it was decided to make them stop and think. The question provided some information about 2 substances of a reversible reaction, and the idea was to devise a plan to show that the reaction is reversible. Student response 005. The answer scored 1. It appears the candidate tried to explain a reversible reaction and got into a muddle, rather than devising an experiment. The mark here was for increasing the temperature, mentioned in lines 1 and 2. There was nothing in the rest of the answer that could be given any marks. All the information about the reaction was provided. It was not necessary for the candidates to have carried this out previously. They were given the equation for the reaction and the colours of the hydrated and the anhydrous forms of copper sulfate, and that heat energy was needed to convert the hydrated into the anhydrous form. So the expected plan should have contained these points. Heat the blue solid. It turns white or steam given off or water produced. Add water to the white solid. It turns blue or heat is released. A tough question, as was evidenced by the mean mark on chemistry being 1.8 and on combined science 0.99. 48% of chemistry candidates scored 0 or 1, and 74% of combined science candidates scored 0 or 1. Questions on planning experiments tend to be answered well by the most able students, but this next question shows that this also can be achieved on the foundation tier. This question was taken from Combined Science 2F paper, question 4F2, which was also question 6F2 on the Chemistry 2F paper. Student response 006. This was a really good answer, achieving 3 marks. The answer had all the detail that is needed for anyone to follow this plan and carry out the experiment to find out what happens to the mass of a solid catalyst during a reaction. The marks were for find the mass of the catalyst at the start of the reaction, remove the catalyst and dry it, find the mass at the end of the reaction. The majority of the candidates taking the foundation paper struggled with this question. About 60% of the chemistry candidates and about 79% of the combined science scored 0. Although a reasonable number of candidates started off by weighing the catalyst, few had the idea of recording the mass of the catalyst at the end of the reaction. Most candidates missed the point about devising a simple experiment, but instead attempted to describe the action of a catalyst, or stated that the catalyst was used up during the reaction. Some areas within all of the papers where candidates did not perform well. Concerning the first 2 points, only about half the candidates could name the piece of equipment used to measure 1 gram of solid and 100 centimetre cubes dilute hydrochloric acid. Instead of balance or scales to measure the mass of a solid, many candidates gave the answer of measuring spoons, and for the liquid, many gave the answer as measuring cups or measuring jugs, and a significant number did think that a ruler was used to measure the mass or that volume. For the 3rd and 4th points, both of these aspects were assessed at foundation and higher tier levels. About the last points, we're not expecting works of art, but something that is recognisable and preferably labelled to ease identification. Here are a couple of areas where improvements could be made and suggestions to focus in teaching and learning. At least 20% of the available marks across assessment of foundation and higher tier level is for testing the mathematical skills as listed in Appendix 1 of the specification. This is a statutory requirement, and the demand is for Key Stage 3 level maths of foundation tier papers and GCSE F tier level maths for the higher tier papers in chemistry. This first example was taken from the Chemistry Paper 2, F-tier question 8C2, which was question 5C2 on the Combined Science 2CF paper. This question presented problems on the F-tier papers that were mostly not seen on the H-tier papers. Student response 007. The marking points here were mass of carbon in 1 formula unit of butane, so 4 times 12 or calculating the moles of butene, so 100 over 58. Then calculating the mass of carbon in 100 grams of butane, 48 times 100 over 58, then approximating the answer to three significant figures. This first example was taken from the Chemistry Paper 2 F-Tier question 8C2, which was question 5C2 on the Combined Science 2CF paper. The question presented problems on the F-Tier papers that were mostly not seen on the H-Tier papers. Student response 007. The marking points here were mass of carbon in one formula unit of butane, 4 times 12, or calculating the moles of butane, so 100 over 58. Then calculating the mass of carbon in 100 grams of butane, so 48 times 100 over 58, then approximating the answer to three significant figures. As can be seen, the candidate did not seem to know how to use the data, and there was nothing here the examiner could credit, so was given 0 marks. If the 207.37 had been rounded to 207, the third mark for giving the answer to three significant figures would have been awarded. A significant figure or decimal place mark is independent of the calculation. Calculators of this type present a problem of foundation tier papers. For this question, 71% candidates scored 0, with only a small number of scoring marks. Compare this to performance on the Combined Science paper, where 25% scored 0, with chemistry candidates performing much better, with only 11% scoring 0. The next example came for the Combined Science F-Tier question 5D on paper 1CF, which was question 8D on chemistry 1F. Student response 008. An empirical formula calculation. The marking points were mass divided by atomic mass for both elements, obtaining ratio for the first step, and obtaining a formula from the ratio in the second step. In this example, the first step was incorrect. The candidate divided atomic mass by mass, so marking point 1 was not awarded. But a ratio was obtained for the first step of 2 to 4, and the second was given. There's no formula used in ratio was produced, and the third was not given, so overall this answer was given 1 mark. Getting the division wrong in step 1 was probably seen more time than those getting it right on the foundation papers. Producing an empirical formula was a rare occurrence on the foundation tier papers. It was clear most candidates were unsure how to handle the data. The performance on the 2 foundation tiers was almost the same as for the other calculation and similar on the higher tier papers. It was even better, with 67% of chemistry and 47% of combined science candidates scoring 3 marks. Concerning good performance, student response 009. This answer came from the Chemistry 1H paper, question 5A1, which was also question 3A1 on the Combined Science 1CH paper. Judging by the way in which the candidate set out the calculation, it looks likely that this candidate did not have a calculator. It is likely this candidate would have underperformed on the later calculations, where the number involved were more difficult to manipulate. The marking points here were converting 1 kilogram to 1,000 grams, divided 142 grams by 1,000 grams, and then converting the value from the second step to a percentage, i.e. multiplying by 100. Despite not having a calculator, the candidate still achieved 4 marks. Overall, this was a high-scoring calculation, with 72% of combined science and 90% of chemistry candidates achieving all 3 marks. This second example also came from the higher tier, question 6C on chemistry 2H, and was also question 4C on combined science 2CH. A relative atomic mass calculation from isotopic abundance data, with the final answer being approximated to 2 decimal places. Student response 010. The marking points were for the mass of lithium-6, 7.59 times by 6, the mass of lithium-7, 92.41 times 7, total mass of 100 atoms of lithium, and divide by 100 to find the relative atomic mass of a lithium atom, and then approximating the relative atomic mass to 2 decimal places. The first 3 steps were achieved in the first, but the candidate introduced a couple of steps into the calculation which negated one step. The 4th step was correctly carried out. A mark independent of the rest of the calculation was mentioned previously. So overall, this answer was given 3 marks. Looking at the performance, 62% of chemistry and 36% of combined science candidates scored full marks, with a mean mark of 3 on chemistry and 2.1 on combined science. Some areas within all the papers where candidates did not perform well. Quite often it was seen on the foundation tier that candidates did not have a calculator, putting them at a disadvantage. This was highlighted previously, but is an issue that can be resolved to help some foundation level candidates. On the foundation papers this summer, we noticed that there were many candidates confused by the negative indices given on the units of density and concentration in particular. So, as shown here, 12 grams to decimetre cubed was often treated as 12 to the minus 3 in the calculation, something we haven't really come across before. Many candidates are still confused about the difference between significant figures and decimal places when approximating answers at foundation tier, and many either forget to do when requested or do not know what to do. This year it was noticeable on the foundation tier papers that many candidates were manipulating the data in 3 or 4 ways. On Chemistry 2F question 4E, which was Combined Science 2CF question 3E, often we saw the mass and concentration manipulated as 9 times 12, 9 divided by 12, 12 minus 9, 12 divided by 9. From that, the candidate often chose the incorrect answer as their final answer, and so no marks could be given, as the incorrect methods negated the correct method of calculating their final answer. On the final point, when the question asks to use data to draw a graph, we do expect a fit of best curve, a best fit curve, or a best line fit, usually straight, as part of their answer. Here are some areas where improvements could be made. Here are some suggested areas to focus in teaching and learning. This final section looks at command words. Most command words used this year were state, give a reason, describe, explain and calculate. In the more appropriate places, give, write, state and devise were also used. Please refer to Appendix 2 of the specification for how these command words are used. It's worthwhile making sure that your students know how to respond to different command words in the examination paper. Have a look at this answer, which came from the Combined Science Paper 2CF question 2E, student response 011. The candidate was asked to explain why argon rather than air was used to fill filament light bulbs. The candidate is given an answer which does not answer the question. Argon does not conduct electricity. But the reason does not explain the first statement. This answer scores 0 marks. In an explain question, candidates should be able to link the statements with because or so to produce the explanation in a logical way. This final example came from the Combined Science 1CH paper, question 3C, which was also question 5C on Chemistry 1H, with student response 012. The candidate has realised that fractional distillation would be needed to separate these two substances in this unfamiliar situation. The candidate then gave a good description that covered all 3 marking points. Use of fractional distillation, heat or boil the mixture, nickel tetracarbonyl boils off first. These presented in a logical way, and this answer scored 3 marks. Here are some common areas where candidates tended not to perform well. Concerning the first point, this is a perennial problem where many candidates try to give several answers in the misbelief that we pick the best answer. This is not the case. Here are a couple of ideas of areas where improvements could be made and a suggestion to focus in teaching and learning. In summary, there are a variety of ways to help improve the performance of students in their examinations. Here are a few more suggested ways to help improve the performance of students in the examinations. Have a look at the more detailed list produced at the end of each of the examiners' reports. There is a great deal of information on the Pearson website, and there's a great deal of support available. No question is too big or too small. Alternatively, make use of Ask the Expert facility with your questions, which can be found in the link to the Contact Us webpage. Some of the support is statistical, and the Results Plus service can provide a lot of feedback about your students individually and as a centre. Many centres find this very helpful. On the GCSE Science page, you will find a variety of uses that will help you to prepare your students for future examinations. For those of you who are new to this specification, you may also find additional sample material from Pearson website to be a useful resource for practice questions. Again, these are available for you to download. Go to the Pearson homepage and follow the links through past papers to GCSE Science. You may also find that the past papers to the International GCSE to be a useful resource for practice questions. Again, these are available for you to download. Finally, we hope this session has been useful, and thank you for taking part in this pre-recorded session.